Good, good. How was the last session, Kevin? Did you like the last session? Can you mention your feedback in the comments? How was it? You had attended the SolidWorks session, I think. How was the session? Good, good. Thank you so much. That is a great motivation for our team. You liked it.
Good afternoon, sir. We are ready for
so
the
meanwhile,
session.
other students join. We can start with the session. Shani sir, can you just help me and put the next slide, please? Thank you, Ravi. Okay. So just to give you a brief, I'll just take a couple of minutes. Kevin, since you have heard our introduction, you can just hear it again. Students, we come from SaiCad, and as SaiCad as an organization, we are 10 plus years old. We are an authorized training partner of companies. If you talk about Autodesk, Bentley, Dassault, PTC, we are also an authorized testing center. You know, Autodesk, the first logo that you can see, Autodesk is a very popular company among engineering, electrical, mechanical, civil architecture students, because AutoCAD is the one software that every student learns no matter which his branch is. There are other softwares like Inventor, Nastran, Fusion 360, Revit, 3DX Max, Maya. So there are a lot of softwares that Autodesk has. Bentley for civil students, STAD Pro, which is a structure and analysis software, is a product of Bentley. Dassault Systems, yes, SolidWorks, the earlier session that we had, and the current session, Catia, both are products of SolidWorks. PTC, Creo, which was earlier called as Pro-E, is a product of PTC. So students, I have seen that, students actually know the names of the softwares, but do not know to which parent company the software belongs. That is very surprising, because when I go for presentations and seminars to colleges, students also do not know that AutoCAD is a product of Autodesk. That is very shocking to me at times. And if you're looking at the next logo, you can see a logo of Certiport there. So Certiport is a testing neutral testing vendor. If you do some trainings for AutoCAD, probably you will have to sit for an online certification exam, and Certiport is an online testing center wherein you can sit for the exam. So all SaiCad centers are also Certiport testing centers. You can take the training from us and also sit for the certification exam at our center itself. You don't have to travel anywhere outside for the exams. Okay, can we have the next slide, Shani? Can you enlarge the slide, Shani? So students, certificates is very important. Every student looks for certificate after their trainings. So certificates are very important, and if the certificates are globally recognized, nothing like it. Because in every city, maybe in Andhra Pradesh, Tamil Nadu, Maharashtra, Punjab, everywhere, Haryana, there are so many institutes, and all institutes are giving their own certificates. So if you're looking at authorized training partners, you will get globally recognized certifications. Like if you're studying Autodesk software from us, you will get a certificate directly from Autodesk. And let us say you are studying any product from Dassault, let us say SolidWorks or Catia, you will get trained, and then you have to sit for a certification exam. You sit for a certification exam at our center, and you will get a certification directly from Dassault Systems, which is a French company for SolidWorks and Catia. So you take the SolidWorks training, you sit for the exam, you take the Catia training, sit for the exam, and you get the certificate. There are various certificates, various level of certificates based on the difficulty level of the subject. So you start with the associate level certification. So if you learn the Catia program from us, you can sit for the first level of certification, that is a associate certification. The other advantage studying from us is, from an authorized training partner, is that you are taught the entire syllabus, the entire curriculum. Because when people normally want to do Catia, people normally want to do SolidWorks, but when you go to institutes, you are not aware what they are going to teach. So they teach as per their own curriculum, and surprisingly, that syllabus and curriculum is only 30% of the actual Catia program. So that is a big problem. Because of lack of awareness among students, these institutes teach you only 30%, and they give you a local certificate, and students are not aware. So, but when you come to us, we will teach you the entire syllabus, entire curriculum as per Dassault system. So whether you are studying from SaiCad in India, or you are studying from any company who's an authorized center in Canada, America, or wherever, whichever part of the world, you will have the same curriculum. And if you learn this syllabus, you can sit for a certification exam. Okay, and then you can get these certificates. So I hope you understand this. And at an authorized training center, you will have a certified instructor who teaches you. So who teaches you is also very important. So like Shani sir is taking your session today for Catia, he is an authorized, he's a certified instructor for Autodesk, for Dassault, for PTC. He has vast experience. So these kind of faculties are going to teach you. You are going to learn on the official curriculum, and then you can sit for the exam. 100% success rate guaranteed for SaiCad students, because we teach you the entire syllabus. Okay, can we go to the next slide, Shani? Yeah, Autodesk. When you talk about Autodesk is since most popular. We are the biggest partner of Autodesk in India. We have the maximum number of authorized training centers of Autodesk in India, right? And we were also awarded. You will be happy to know that SaiCad is the #1 academic partner of Autodesk in India. You can see the award ceremony. You can see the SaiCad team getting an award from Autodesk in the last event that was held in Pune. So we are the #1 partner of Autodesk, not only in India but entire SAARC nations. So congratulations to our team for achieving this. This has only been possible because our students have given an excellent feedback to our trainings. And that is what the Autodesk team evaluates, because whenever you do a training from us, you give a feedback, and the Autodesk team evaluates the feedback of the students of every company. So we are teaching maximum number of students in India today from Autodesk curriculum, right? Okay, can we go to the next slide, Shani? This is the map of India. We all are aware, but if you can see the mustard part, so you will find SaiCad centers in all states, right? You can just visit any of our centers. When the lockdown opens, you can have the wonderful classroom learning experience from our certified faculties from all states. Meanwhile, our team is teaching you online, and we are already running many batches wherein we are teaching students from across the state, and students are loving it. Trust me, they are loving our online training. They are getting the same training at 1/3 the fees. A fee of a program that was, let us say, 15,000 rupees in classroom. They are getting the same training taught by certified instructors, sitting in the comfort of their home, only for 5,000 rupees, for example. So that is a beautiful advantage that students can get. Okay, so you can also take advantage of online training sitting at home. And the reason why we are conducting these demo classes is to give students an experience to how online training is. There is a big myth. There is a big myth in students. Students today feel that they cannot learn online. It is very difficult to learn online. Many students told us, sir, we will come to your center when the lockdown opens. We will come to your center and learn from the faculties. You are most welcome to learn. But if you are getting the same course at 1/3 the cost, and the same teacher is teaching you online live, wherein you can ask him questions, what is the use of spending 3 times the amount? Come to us, learn from us. And if you have any doubts, please come to our center once the lockdown opens. Come and clear your doubts from our centers. We are not going to charge you anything extra. Okay, can we have the next slide, Shani? Or can we have the video? Yes, Shani, I'm putting the mic to you. Please explain them, Catia, as well, along with the video, and I will join after you finish the video.
Thank you, sir. So good afternoon, everyone. My name is Shani Goel, and I'm an certified instructor from Autodesk, Dassault, and PTC. I have worked around long 7
your
to 8
voice
years.
is not audible.
Industry. Hello. Is it okay now, sir?
Hear Shani's voice. I cannot hear him properly. Can you hear his voice? Can you mention in the comments box?
Okay, can I please? Okay, sir, I'm audible to them. Okay, so
Shani, can you play the video first?
Okay, sir. So this is the video of CATIA. In this, we have explained the modules that are available in the CATIA. So first of all, we have the sketching. In that, we will create the sketch for the part modeling. Okay, the part modeling is simply the solid modeling or the surface. Everything will be created in that, and after that, we will assemble all the parts in the assembly. Then we have the drafting and detailing. In this, we will create a complete, fully defined or fully detailed drawing. Then we have the sheet metal, the components that are created with the help of sheets will be covered in here. The surface modeling for plastics and complex shapes, the machining for the cam. Okay, then we have the simulation to analyze the structures. And we have the kinematics to study the motion of the assembly. Then we have the renderings. Okay, so in the rendering we can create the part. Okay, then we have the certificate.
Yeah, yeah, students,
Okay.
this is the authorized certification. A student needs to clear the exam. You can learn from us, then sit for an online exam, and then you will get this certificate directly from Dassault Systems. And this certificate is globally recognized. You go for a job, and if you show this certificate, you are guaranteed a job because you know everything. The employer also knows that student who is certified has perfect knowledge in CATIA because you have certified. Students who are not taking certification exams, you do any course, you get a certificate from any center. That certificate has no value. Please understand, those certificates have no value. Just sit for the exam after you have completed the training. And to clear the exam, what is important? You need to do the complete syllabus. You have to study the syllabus as per the Dassault curriculum. And if a certified faculty like Mr. Shani teaches you, you are guaranteed success. Trust me. So uh, let us watch the complete video again. Shani, don't give any pauses. Just let us go through the video once, and then we can start with the session. Companies that use Katia as a software for okay, students who have joined in late, just to introduce yourself in the comment section, please write your name and your state. Just write your name and your state in the comment section quickly. Let us welcome students who have just joined in late. I've seen a couple of students who have just joined. Just mention your name and the state you belong to. After the session is over, we will share a feedback link. We have already shared it in the WhatsApp group. We will share it again. Please, it is very important. All of you students, after attending this session, spare please 2 minutes and give a feedback. Now, after this sessions are over, we are going to get over with the sessions today night after all the demo sessions. And tonight, we are going to give you a wonderful offer, a wonderful fee offer for you to join. And please avail that offer. I'm again requesting you to avail that offer, because that offer is only available to students who are attending this session. And you avail that offer will be shared with you tonight, and you can avail that offer till tomorrow. If you enroll till tomorrow, that offer is valid. After tomorrow, you will not be able to take that fee offer again. I'm telling you again, I'm going to share a wonderful fee offer tonight, and you can avail that offer till tomorrow. After that, you will have the regular fee. So do not miss that opportunity. You can deposit the fee online. We will share the registration details. You can pay through Google Pay, Phone Pay, or through Paytm, or you can deposit it online, your fee online to our bank account. But please avail that offer if you are really serious about doing Dassault Katia from us. Thank you so much. And don't forget to fill the feedback form after the session is over. Over to Shani, and I hope all of you have a wonderful learning experience with Shani, sir. Thank you.
Thank you, sir. So good afternoon, everyone. So we are going to start with the KTIA, and before that, we are going to see the product design cycle, why we are using the software, what are the design concepts we use, how we use, what is the procedure. So you can see on your screen, we have the product design cycle. To create a product, we need to create some several things. First of all, we need to have the concept, we need to have the idea, what we need, what is the need of that product, what will be the functionality of that product, and that will be created with the help of some rough sketches or some rough calculations. After that, we will create some engineering design with the help of that rough sketch or rough idea. We will use software, the CAD software. It can be SolidWorks, it can be Creo, it can be Catia, it can be NX, whichever you need. There are several softwares available in the market. So we like here we are using Catia, and we will create the parts, we will create the assemblies in the software. After that, we will move to the simulation. In the simulation, we will validate, we will analyze the component, we will test a structural analysis, we will test its structure. For failure, we will test, like we can test the thermal, we can test the aerodynamics, we can test everything in the softwares. Okay, this will be the digital prototyping, not the physical one, because till now we will be in the software only. So after analyzing the whole component, after analyzing the whole product, then we will create the documentation for the component. We will create the drawings, fully defined drawings. We will create the drawings for the manufacturing also. And then we also create a visualization. You can see there is a visualization. There is a component that is, the component has been provided the textures, the material is applied. Okay, so it will be a realistic looking product available to see. Okay, so after that, we will create the master part, or we will create the prototype that will be the physical, and then the process will begin from there. So to create a product, we have some simple steps. For CAD CAM CA, you know, the first thing we have is CAD, second is the analysis, third is the manufacturing. In earlier days, the CAM was after the CAD, then we was able to create the we will able to test the part. Okay, but now we can create the design in the CAD, we can analyze it in the engineering option in the software, and after that we can create the manufacturing also. So CAD means computer aided design. It can be created with the Catia, with the Creo, with the SolidWorks, or even with the AutoCAD also. Okay, then analysis, you can use any software for the analysis. It can be NSYS, it can be SolidWorks, Catia. You can use all the softwares for the analysis also. And then we have the manufacturing, computer aided manufacturing. In that, we will create the programs for the parts, like this one. We have like NX, we have the Catia, we have the SolidWorks. Everyone has its CAM integrated inside the software. Okay, so next we have the softwares for CAD. The best drafting software, we have the AutoCAD, and the basic and advanced 3D modeling, we have the Creo, Catia, SolidWorks, Inventor, and Fusion 360, and also the NX CAM. NX, Siemens NX. Then for the manufacturing, we have the Fusion 360, we have the NX CAM. We can use any other software for that. And the analysis, we have the ANSYS and Nastran that are master, but we can analyze the structure in the SolidWorks also, in the Catia also, in the Creo also. Okay, so let's start with the Catia. So first of all, here is the software. Okay, wait for a second. Okay, so on your screen you can see I have opened the software. This is the Catia V5. Okay, version 5. Then in this you will see this is the first blank option. We can start it from here. So in the Catia we are going to cover the sketcher, the part design. We will see the assembly also. We will see the drafting also. Okay, we will see some parts that we have already created. So first I will show you some components that that was created earlier. So right now for the part, it will take a few seconds to load. Okay, so you can create components. Now the Catia is a different software. It will not work like SolidWorks, not work like Creo. We have some different options. We have to understand the software first. It's like you want to zoom, it is a different option for zoom in, zoom out, for rotation. Everything is different here. So you need to learn everything for to control this software first. Okay, so we have some different products here, parts here. Okay, like that. If you want to create some helix, like you want to create a hook. Okay, so these are just sample. These are not perfect. This is just a sample. What type of part can be created. Now I will go for the completed parts. Like, okay. Okay, you can see here we have some components. It's not a complete assembly, but right now we are in the assembly. You can check whether you are in assembly or part modeling by just looking here. If there is product, if the product is written here, means you are in the assembly. If part is written here, means you are in the part modeling. Okay, so this is a simple part. It's not assembled in kinematics. We have for motion, we have the kinematics here. It's not like SolidWorks. You cannot move the component in the simple assembly. You have to apply some kinematics, some motion, some linkage to move the component. So it's a simple assembly. You can just drag and move the component from here. In Catia, we have some options, some tools. We have to move the tool. Okay, we have to choose the tool directly from here. So choose the tool according to here. If you don't see your desired tool, just right click and insert the tool that you need. Okay, like I need instant collaboration right now, so the tools will be there. Okay, so sometimes the tools you will not see some tools here. You have to find them. So we have graphics, we have, okay. Okay, so we need to move to the assembly design from here. If I go to the assembly design, my tools will be there. You can see now I have some other tools here. So you can switch between windows, you can switch to part, you can switch to assembly, you can switch to kinematics directly inside a file. You just have to go to the mechanical design, you can just select the part design, you can just select the assembly design, or you can switch to the shape, and here we have the generative shape design. Okay, then we have digital mockup. Here we will have the DMU kinematics, from where you can apply the kinematics. Okay, we have the kinematics tab here. We can just drag that tab. You can see that these are the DMU kinematics. You can apply any type of motion, any type of joint directly from here. You can see this is the Revolute. Okay, this will be the prismatic, this will be the cylindrical. We have so much type of constraints here. So we have some limited time. So first of all, I'm going to start with the sketcher. Going to close that. Okay. So again, we have some parts for the assembly also. If you see here, we are in DMU kinematics right now. So you can see here, this is the mechanism here. Okay, if I see here, okay, we have the simulation available also. Okay, we need to move the component. So let's close. So select for a new file, just select file, new, or you can go here and select the part. I have customized this option. You have to go to the mechanical design, then part design, and you can just select a new part. You see here, we have the new part option here. So define your name, click OK, and a new file will be opened. Now you will see this is a part body. You can see there is the part option. So this is a part body. You have to create a part here. So this will be the solid modeling. In this, you will have a tree here. You can move this tree up and down. You can change the scale of this tree like that. Okay, if you want to zoom in or zoom out or pan, you have to use the mouse. The middle button will pan the screen. The middle button with control will zoom in and zoom out like that. So first of all, we are going to use the sketch. Here you can see this is the sketch tools. And here you will see we have some shapes here, that is sketch based features. You have some dresser features. You have some reference elements, and here the transformation features. Okay, all the features are there. I have just moved them for my view. I like them to put up here, so it's easy to select. So first of all, I'm going to use the sketch. To create a 3D, you need to create a sketch. So like I want to create a box, I just have to create a sketch for that. I just have to create a rectangular shape for that. So select the sketch, select the view or the plane from here where you want to create the sketch. You can select it from here also. Select the plane and it will orientate itself. Then we have the profiles here. Okay, so I need a rectangular shape. I can just create a rectangular shape. If I need a circular shape, I have a circular shape here. All the types of the rectangles, these are called predefined shapes. The circles, okay, we have all the shapes here. Whichever you need, just select and like that. Okay. Next thing we need to do is to define the dimension. The size need to be defined. So we have the option here that is called constraints. In the constraint, we have the constraint option. Select that, select the line. If you want this height, select this and click here. If you want the between gap, select again, select two lines also. You can select two lines and there will be the between gap if those lines were parallel. Or or you can just select the single line, or you can select 2 points. We have multiple options to select to define the component. Okay, first of all, if you have any question, if you have any query, you can ask. Just unmute your mic and ask the question if you have any. Okay, so to add it, just double click, define the value. Okay, it's 30, double click, it's 40, like that. So it's defined. So like SolidWorks, we have again here the color options to check the object is defined or not. In SolidWorks, we will have the black or blue options. In here, we have white and green option. Green means the object is fully defined. The white means it's not defined. It can be like that, but green will stay on its position. So basically, we have to apply some relation to define the component. So for that, define the dimension. Okay, I want it to be 15, and I want the diameter to be 15, and I want it to be 20 from here. Okay, you can see it's fully defined. I don't need this slot, so select it like that and press the delete button. Or okay, we are currently in the command, that's why I'm not able to select it. Press escape, okay, and select and press delete, and it will be deleted. So always place your tabs, always place your tools at some desired locations. Okay, so if you close any tab from here like that, you can always right click here and open that. Like I have closed the profile right now, so I can open the profile. So just place that where you need. I don't need this circle. Okay, so this is the sketch. Just exit out, and here we go. We have the sketch. Now to create a 3D model, to convert this into the 3D, we have some option. Right now we are in the part, so we only have the solid modeling option here. In the Catia, we have to choose the module from here. If you want the surface, if you want the sheet metal, you just have to go to different option. Like here we have the generative shape design. If we go to the mechanical, we have the wireframe and surface design. We have the generative sheet metal design. Okay, we have assembly, we have part. Right now we are in part. So next option, we will need to convert this to 3D. Right now, I just want this to be extruded. I just want a material that is straight, normal to this sketch. So for that, we have the command that is called pad here. In Catia, we call pad. In SolidWorks, we call extrude. Okay, we have different naming in different softwares. So select the pad. I have already selected the sketch. So right now you can see it will convert that sketch into a 3D model. Okay, so we have some options. We have some tools here. You can see this is the pad definition. From here, you can control whole software, whole command, the pad one. We have the first limit. If you go to the more, we have the second limit option. Right now, we are in the single direction. If you want to go to the other direction, we have the reverse also. We have the mirror also, or we can define a value from here. You can see it will create in the other direction like that. Okay, so just click OK. If you want to see it hollow from inside, we have the thick option. Okay, if I click on the thick and preview, you will see like that. If I remove the thick preview, you will see it like that. So click OK, and here is the component that we need. Okay, so in this way you can create a solid part with the help of pad. If you want to create a circular part, so you can see this is the model tree here. In the model, we have the part body. In the part, we have used the sketch, and for that sketch, we have used the pad. So that pad will consume the sketch. The sketch will be hidden. Okay, if you want to see the sketch, just right click and hide show, and the sketch will be visible. You can see the sketch here. Okay, I don't want to see, so hide show, it will remove that. Okay, so this is the part. I don't want this part right now, and so I can just delete it. We have some option, and just click OK, and everything will be deleted. Okay, if you want to delete only the pad, don't want to delete the sketch, then remove this one, click OK, and we have the sketch left, and the pad will be deleted. Okay, So if you want to convert, if you want to create a surface, if you want to create a circular entity from this, you have need to add an axis. So from sketch, I'm going to use a line for the axis. Okay, I'm going to convert it into construction. You can see this is the construction geometry now. Okay, exit out. Now we have the second option that is called the shaft here. So from the shaft, you can create a 3D part. You can see we have the selection for the profile, but we don't have any axis. So for the axis, you can select the axis from here. You can see we have some axis here, or you can just right click here and select Y axis, X axis like that. So I have selected the Y axis, there is axis, and it will create it to the 360 degree. If I use the angle, like I want it to be only 180 degree, so you can see we have the object. Okay, so you can just create an object from a sketch and convert that into 360 degree, and that will show some option like that. It will create like that. Okay, where you use these type of shape, like I want to create a pulley. So for that we need to create a sketch, or I can just directly select the shaft, go to the sketch here, select the plane from here, and I can just create a sketch. So I'm just going to create a quick sketch from here. Okay, so we have some trim options here. I can just select them and trim like that. Okay, so this is just a rough idea. Click exit. Okay, yes, select the axis of rotation. Okay, so if you see here, we have the object. Just click on the preview. Okay, several open contours. So we have some errors in the sketch. So in Catia, we have option to analyze the sketch. We have the sketch analysis tool. So in the tool, we have the sketch analysis, and we can analyze that there is a line that is extra. We have an implicit closed profile. So select that extra line and delete it from here and close. So if you exit out and select the axis, you can see the preview also from here. So like this way, you can create a pulley also. So any circular entity you need, just draw the half sketch and you will be able to create it in the 3D. Okay, so if you need to see it in 360 degree, you can see this is the complete pulley like that. Okay, any question? Okay, so after that we have some command like sweep. In this we call it rib. We have command like loft. In this we call it multi-section solid. So we have to just create the part here and we can just assemble that part. So I'm not going to create anything because we have limited time. So right now, just going to exit out from here. I don't want to save it. Now, how you can assemble anything. So go to the mechanical design. Next, we have the assembly design from here. Okay, if you need any answer, if you want to have any answer from me for your questions, just let me know, ask your question and I will answer that. So in the assembly design, we need to insert a component. For that, we just have to select an option from here that is called the existing component. Okay, select that and click on the product and you can just insert a component from your assembly or from your location. So right now I'm going to use some components from here. So we have a mechanism, we have some files. I can select multiple files also. Open. Okay, so you can see everything will be added into the assembly. You can see all the parts are here. So in the assembly, it is very different scenario. In this software, we have some different option. It's not like Catia, Creo SolidWorks. It's a different approach here. You just have to first separate everything from here. So for that, we have some option in here that is called the manipulations. So they should be right here somewhere. Okay, so we have a tab here that is called the manipulation. Okay, this is the move tab. So in move, we have first tool that is manipulation here. Okay, if we click in the manipulation, we have the manipulation option. So I'm just going to attach it up here and now. So we have some directions here. We can move the object in the X direction. We can move it in the Y direction. Okay, we can move it in the Z direction, or we can move it according to an axis which I select. The object will be moved according to that. Okay, I can select any axis and the object can be moved in that direction, like that. So select the component you want to move and move it like that. Okay, so here we have all the components. So next thing in this Catia, we have to create an assembly, but with very different approach. We just need to move the component. We just need to rotate the component first. Then we can use the constraints here. Okay, so we have all the move command here, and for the constraint, we should have somewhere here constraint options. Okay, these are the existing options and components. Okay, we have some option down here also. I'm just going to, okay. So we have the constraint here. So in Catia, you have to find everything according to your need, and then you have to place it. So that's a very different system. So now we need to apply some relations. So here we have the manipulation, but we also have snapping option. We can just snap the option, or we have the smart move also. So we can just select the component. I want this component to be here. You can see we have the automatic constraint option here. We can assign the constraint also. Okay, I need that component to be flipped. So click here, the component will be flipped like that. Okay, so you can see we have applied a relation here if you see the green option. But object can be moved front back from here. Okay, I can just only check it like that. If I want to move it in X or Y. Okay, it can be moved in Y, but if you check with respect to constraint, okay, then it will get back to its location like that. So first of all, this is the base. We need to make it fixed. So we have the fixed constraint, select that. And now if we select the manipulate option, if you go to the X direction, we can only move this one, not this one. Okay, so we need to apply some relation. So for relation, we have the first option that is called coincident constraint. I can select one face here and one face here. Okay, and there is the relation. I need similar. Okay, I need the opposite face. This is selected here. Click OK, and the relation is added. Now we need to update that. Okay, it will not update automatically. We need to update that every time. So here is the option that is update. So like this way you can just use the relation. So I need to attach this one here. So use the smart move instead of the move command. I need to attach this edge to this one. Okay, I need that to be flipped. Click here. It is flipped now. Okay, so we have a relation inside. So move with respect. So you can just move it like that. Okay, so define the relation whichever you need, and like I need a coincident. I just want to coincident this face to this one. Click OK, and I just need another coincident that this feature is coincident to here, this face. Click OK, and now you have to update it. You can see we have the component attached. Okay, so this is a simple assembly. It will not work because we don't have any motion. We can just check it from the manipulation from here. Like I want to rotate it according to the axis, so I can just select and rotate it from here, but it will not work properly with the motion. Okay, for relations for the motion, we have the second option. Go to the start. Now we have the digital mockup, then we have the TMU kinematics. So in the kinematics, we have some options like TMU kinematics we can add, and we have the joints. The joints will came out from here. Okay, so I'm just going to place it here. So now we have to apply some relation. So you can see we have applied some relation here, but I don't want those relations, so I can just select them and delete them. Like delete here, delete this one, delete this one, and this one. We can delete it like that, and if you need any relation, you can add that from here also. Okay, wait for a few seconds. We'll just update. Okay, so how to add a motion? How to add motion? Like I want to rotate this, so we have some option. Okay, this should be fixed to this one. I just need the motion to be added here. If I go here, we have the Revolute joint. Okay, so in the Revolute, you have to add some mechanism. You have to create some mechanisms. First of all, I'm going to delete every constraint that I have applied earlier. Okay, so to move the object, you will again have to switch back to the assembly. So that's a very annoying situation here. But right now, I just want directly to apply a relation. So go to the Revolute, and if you go to here, you have to create a mechanism. So click on the new mechanism. You can see we are going to create a mechanism one. Click OK. Then and the name is Revolute. If you want to change the name, you can. Then you have to select a line. So there is a line for this one. There is a line for this one. Okay, then we have to select the plane for the motion. So we have a plane right here. We have a plane right. We should. Okay, so we have to move the component, and we can also do that. We can just hide this component, and we can select the face from here. Okay, so if you want to rotate the component, we have the option that is angle driven. I want it to be angle driven, so just click on that, click OK. Okay, and go to the visible, go to the height show, and go back to again switch. So here we have the component. Okay, so like that, you can just insert your components right here. Okay, so if you want to check, we have some option here. Simulation with commands. So first of all, we need it. Okay, so I have not defined the constraint here for the fixed part. This constraint is from the assembly. That's why I didn't get any update here. So select that, delete that, or right click. So we have a constraint here. I can just delete that from here also, like that. So we need to have a relation, a constraint here. Click here. Okay, now you can see there is a information that the mechanism can be simulated. It means the motion can be applied. You can verify the motion also. So assembly constraint conversion here, from here you can convert, or we need to move. So here we have the option for the simulations, GNU generic animations. So from here we have option for the simulation. This is the mechanism one. I want to simulate that. So from where you want to simulate, I need to simulate that from here. Okay, you can see that the shaft is turning from here. Okay, check joint limits if there are any. So there is no limit. I can just click here. Okay, so you need to add a frame right here. Okay, I need that to be 01. Can play that. So you can see we have the motion here. I think you will be able to see that. We have the motion here. Okay, if I just click here again, so the motion is like that. We need to apply the loop to make it rotate on the clock. Like, so is there any question? So these are the GNU kinematics. We have so much commands, but not able to complete everything here. So just shown you a simple option how you can create that. Okay.
Hello, sir.
Yes.
If we want to copy any part in assembly, so how we can copy that?
Okay. So you want to copy this one?
Okay.
Okay. Here. So we have the copy instance. We can. Okay, wait for a second. Right now, select destination. I want that to be part cannot be. Wait for a second. Copy option. One thing is that you can just insert that component, but for the copy, here the option, the copy option can paste that also. We have the part 3, part 2, part 1. Need to copy instance, and we can. Okay, so here is the option. Because I was using it after a month in the assembly. So okay, so just right click. We have the copy instance. Just click on the part. Sorry, product, and here is the other part. Now you can just manipulate it. Go to the mechanical design, assembly design, and we have the manipulation from here. You can just manipulate it directly. So we have the component here.
Okay. Thank you, sir.
Okay. No, I'm not going to teach everything because we don't have time. I have a next session at 6 p.m. So we only have 12 to 15 minutes. Because on 5:45 I have to start the next session. Okay. So in this way you can just create, because if I'm going to create everything here, it will consume 10 to 15 minutes to just animate everything. Okay, just the idea is that you can just assign the kinematics from the kinematics here, from the digital mockup. Here is the kinematics. You can apply the kinematics from here. There are the joints. Apply the joint, then animate that from here, from the simulation. You can test that from the simulation from here. Okay. If you have any simulation, you can just go here. We have the option to simulation player. We can check. Okay. There is the simulation player. If you just run the simulation one time, it will get that, and it will try to animate that itself. So the next option will be the drawing. Okay, so in the mechanical design, we have the part, we have the sketcher, everything. Now we have the drafting here. Okay, we can go directly to the drafting from here. Okay, now it will ask, we have the new drawing creation option. It will ask what you need. You need a blank, you need with all the views, with first angle, with third angle. Both the options are there. So like that, I want this view. Okay, sorry, I need this view. So you can see global scale is 1:1. Paper size is 841 by 1189. It's around A2 or A1 sheet. I think it's A1 sheet. Okay, A0, sorry, A0. Okay, so standard ISO A0 sheet. Then we have the size. If you want to modify, you can select it from here. I want an A3 sheet. Okay, and I want that in landscape. Okay, okay, and we have, okay, it will try to insert the views directly into the drawing. Okay, so you can see here the component that I have inserted is right here. Okay, so in the A3, our sheet is this one. The component is bigger because we have the scale 1:1. So we should have changed the scale. We can do everything from here. We can change the scale also. We can insert the views also. We can insert the dimension also. Everything can be done from here. So just select that. Okay, and we have all the option here. So first thing is the views. Okay, then we have the option for the drawing. We have the option for the dimensioning, for the tolerance. Okay, in the annotation we will have the option for the tolerance. We also have the sketch tools right here, and we have the option for the multiple sheets. Okay, so define everything here. If you want to insert the dimension, you can insert the dimension from here also. So right now I just don't want these views, so select the view. I can just delete the view like that. Okay, so for the view, if you want to insert any view, we have the option for the views here. Okay, like I want to insert a front view, so select the view. Now select a reference plane on a 3D geometry. So where you want to, so first you have to open the component also. So file, I'm going to open. You have to switch front and back, and from there you can select. So we have a folder here, that is folder, where is new folder 2. Okay, so I'm just going to open a new file. Here we have the coupling. Okay, we have the base here. So open. Okay, so we have the here view here. So I just need to select the face which I need to open. So go to the window, you can switch directly from here. So okay, so select an object or command. So go to the front view. Okay, select a reference plane on a 3D geometry. So for that, okay, I need this to be front view. So you can see that if I click here, it will go back to the drawing, and here we have the view. Okay, so from here you can insert the view. So just click outside, the view is here. If you want another option, this one. Okay, first. Okay, this is front view, unfolded view, view from 3D. Okay, all the three views, projection views and auxiliary. So now I need some other views. So go to the projection. Now you can see we have the projection here. Go to the projection, we have the projection here. It's from the bottom. Okay, if I go downside, will be the top, because we have selected a different type. It will be created according to the first angle or the third angle. Okay, so if you need an isometric view, select the component. Okay, For the isometric, you will have to select a reference plane on a 3D. So again, you will have to go to the part and you will have to select the view from there. Okay, so you have to first define the view, like I want that to be isometric, but from different angle. So select that, switch. Okay, so I need that view to be somewhere in this direction. Like that. So just click anywhere and the view will be inserted. Okay, like that. So just place it where you want. Just click outside and the view will be there. So these are the options. For the dimension, you can just go here. Okay, part 1. Okay. Okay, so all the dimension from the part can be inserted directly inside this. So we will have some repeated dimension also. So all the green dimension means everything can be updated directly from the component. If you just click here, you can see this is the tribe geometry. You cannot change it from here. Okay, so like we can see here, we have the 30 gap. Will take some time to edit any view. To edit anything in the view, you just have to select that view. Double click on that. So the view will convert to the red, and you can just edit anything from here now. Like that. So whatever you need, just keep that and remove everything else. Okay, so like that you can insert your options. So just create it like this. I don't need this one. I don't. Okay, I need this one, this 30. I don't need this 55, but I need this 120. I don't need this one. I need this one also. I need this one, but not 120. And in here, I need this 20. Okay, I don't need the previous values from here. I just need this one and this one. So these are the option. If I go here, double click on the scale, you can see this is simple text editor. I can change that. If I type that 1:2, okay, 1:2, click OK. So it's just a text. Okay, nothing is going to happen here. Just a text. Okay. So we have all the properties. You can just right click and select the property. Here is the scale, whichever you need. I need 1:2. Apply. Okay, so you can see that this view will be converted to 1:2. If you want everything in 1:2, just select those like that and right click and properties and select the scale from here. And here we have the scale. Okay, so these were the option. There are so many options, but we don't have time. So just going to show you fast and forward. So like this way you can create, and now going to show you some part from sheet metal from surface. So going to open directly. We have a, I think we should have a CPU somewhere here. Okay. And this is just a water cooler motor that is used in normal household coolers. Parts here. Okay. Here is the sheet metal. Here is the CPU component. Here is the product. Okay. So here you can see this component. This is a CPU. It's my PC CPU. So this was created by a student of mine a year ago. So you can see here we have everything. I just don't want to see some things from here. Okay. So if you open any component, you can select the component, right click, part 1 definition, or open in a new window. So here you can see we have some side views. This was created with simple pad pocket, but go here, this is part 7. Okay, so this component was created with sheet metal. Here is the front part. Okay, this one is the front part. This is again solid. So just open that component. Okay, so this one was the component that was created with the help of sheet metal. Okay, so we have used some option from here, some wall options. So here is the wall option. We have tools, go to the file, mechanical design, and we should have a generative sheet metal. Okay, here is the sheet metal. Okay. So we have the tools here for the sheet metal. We have the wall tools from here. So from here, this wall was used. You can see the wall was used from here. You can create a wall directly from here. Okay, we just have to create that wall. We just have to create that sketch for the wall, and that will be created like that. We have cutouts for these cuts. We have the wall on edge like that. We can just select the edge. We can use the wall on edge from here, and we can add a wall. If you see here, we have a wall on edge. So it will require some time to complete, but you can see here, this is the option. Just going to delete that. File, open. So right now, the surface here, okay, back panel. Okay, so in surface, I just open this one, don't know if it's complete or not. So you can see this is a simple bottle. It's created with the help of surface. It's not complete, I think, because it's not hollow from inside. Okay. So for the complex structure like plastic molding structures, we use the surface. For the complex, like for this cut, we can create this with the help of solid, but to create these cuts, we need to use the surface options. Or for we have another part. For this one also, I think it's created in the surface. Okay, no, it's a sheet metal component. It's in the wrong place. Okay, so these are just created by the students. So you can use the surface bodies to create. So you can see there are tools used like split, like extrude. It's like solid modeling, but everything will be created with the help of everything will be created in thin surface with zero thickness, and there is some thickness applied. So I go up to here, define in workpiece. Okay. So here is the shape that is created with the help of surface tools. So everything is separated, everything is created separately inside of this one. So surface tool will be used in case where you have to create like you create the car body, like you create like the software is used for the aeroplane bodies also, or for the boats. The surface will be used in there. Okay, so we have all the components like this. So right now time is over. So if you have any question, you can ask that. Do you have any questions? Because we have a reminder here for the next class. If you have any question, you can ask that, or we can just close the session from here. Any questions, please ask. You can type that question also. Okay, so Catia is a software that is used mostly for the surface modeling. It is used, the first version was created in 1977, and it was created to create the plane that is Mirage 2000, that was created and developed in this software. If you are in Punjab, there is a company Sonalika, or the ITL, International Tractor Limited. They uses this software, and we have some another company, I think that is Pin on something name, that is using this software. So multiple companies uses this software. Most of the companies, the bigger companies, because this is the most costly software in the market, against SolidWorks or Creo. This is the most costly seat. I think it will cost around 20 to 22 lakhs for one license only. Okay, so it has very huge application, but in mostly in the surface modeling or the PLM. Okay, so if you have any question, just ask that. Our session is complete now. Okay, thank you very much. I'm going to close the session now.